Today's going to be 30-1, angles and their measure. Today we're going to be able to define an angle, examine angle measure, radians, degrees, draw angles in standard position, define radian measure, and draw and find coterminal angles. So we're going to start with the boring old ray. Now basically a ray is half a line, or at least it starts with a point and extends on forever in the other direction. And so this would be a ray with initial point P. Now when two rays share a common initial point, like in this case, it creates an angle. And that common initial point is going to be called a vertex. So this is an example of an angle, okay, with vertex P. This is an example of an angle with vertex Q. Now just to kind of note, there is a difference between a straight angle and a ray. Remember, it starts at a point and goes on forever. A straight angle, on the other hand, represents there being some sort of rotation getting to that other ray. Or at least I should say there's two rays going on in both directions like that. Now if I were to say that the measure of an angle is a number which indicates the amount of rotation that separates the rays of the angle, there's a problem with that statement. It's way too vague. And so if I look at this angle here, am I talking about this one or am I talking about this angle? I don't know. I don't know what it's asking me to actually qualify just by that angle. And so to alleviate that scenario, we name them. And I would say that this is going to be angle alpha, and this angle here would be angle beta. And so if I were to say, what is angle alpha, then you would know that I am trying to find this angle here. So just to note that, just to remember that, we're going to name them so that we know how to find them. Now a couple of qualities to be able to help us measure what this is going to be. If I have a ray and it starts and it goes one full rotation, one revolution is 360 degrees, which means half of that, so this half rotation here, even if I cut 360 and divide that by 2, that's going to be 180 degrees. And then if I take that 180 degrees and cut it in half further, I'm going to get a 90 degree rotation. And I could even cut that even further. If I know that that's 90 degrees and I cut that in half, well then that's going to be 45 degrees. And you can keep cutting it in half to kind of imagine how much of this angle am I really needing. Now also, when we examine degrees, they always have that symbol there. So this symbol, that's how I know I'm using the unit degrees. So just know that, because radians and degrees, which we're going to talk about radians later, radians is a form of rotation. It measures rotation, just like I would say feet and yards, two different units, but they both measure distance. Angles and radians, two different units, they measure rotation. So a few qualities and properties that angles have and how they relate to each other. If an angle measures strictly between 0 and 90 degrees, we call that an acute angle. If an angle measures between 90 and 180 degrees, we call that an obtuse angle. If I add two angles together, in this case it'd be two acute angles, we call them complementary angles. So notice this angle here and this angle here, added those together and it gave me this 90 degrees here. So we would say that those angles are complementary. And so I would say theta plus gamma equals 90 degrees. Now if two angles, or one being acute and one being obtuse, or two right angles, etc., we'll say that they're supplementary if their measures add to 90 degrees. So that means that alpha plus beta in this instance, we're going to equal 180 degrees. So supplementary, or they are the supplements of each other if it's 180, complements of each other if they add to 90. Now it's also important to kind of think about how the angle is going to be oriented. It's always easiest if we say we have some sort of initial side, which is where the angle is going to start, and then it rotates, and we call that rotation. That's our angle, and where it ends up, we call that our terminal side. So the initial side is where it starts, the terminal side is where it ends up. Now there is a difference between the two types of rotation. I could rotate this way, or counterclockwise, and we call that a positive rotation. If I rotate this way, or clockwise, that's going to be a negative rotation. So just remember, counterclockwise, rotating this way, that's going to be positive rotation, and then rotating this way is going to be negative rotation. We also say that an angle is going to be in standard position if the vertex is on the origin. So the vertex is on the origin, and its initial side coincides with the positive x-axis. So vertex with the origin, and the initial side corresponds with the positive x-axis. And we can classify those angles based upon where its terminal side lies. So this first one, it says draw 135 degrees in standard position. So it helps for us to kind of draw this out. There's my axes. And I know that from this previous thing we said that that's going to be 90 degrees. And we know that if it's going to be in standard position, we know that my initial side is going to be here. Well, I know that I went 90 degrees, so let's kind of subtract 90 degrees. How much do I have left? I have 45 degrees. And so that means I need to travel 45, and I know that 45 is going to be half of this. And so then the distance here, that's going to be 45. And so I have an idea now where my angle is going to be. So to draw this neater, I can say that there's my initial side. That's where it's going to end up, and so that's going to be a 135 degree rotation. 200 degrees. Same idea. So if I'm going to start here, and my vertex is going to be on the origin, and here's my initial side here, and I need to draw 200 degrees. Well, it's bigger than 90. It's bigger than 180 degrees. And so maybe and I know that 180 degrees would be this, so maybe minus 180 degrees, and I'm left with 20 degrees. So I know that this would then be 45 degrees, because that's half of the 90. Well, half of 45 is about 20, so I'd say that's a good enough estimate there. And so drawing my answer, I can say that my initial side, and then trying to kind of copy that correctly there, we're going to say that that's going to be my rotation. So that's going to be 200 degrees in standard position. Let's try drawing 470 degrees in standard position. So drawing this out, I know that this is going to be 360. So if I subtract 360 from that, I'm going to be left with 110, which means I can rotate another 90 degrees. And so that's going to be 90 degrees. I'm left with 20. And so if this is going to be 40, about half of 40, so we can say that that's maybe approximately 20 degrees. So that means my final answer, if I wanted to draw that out, here's my initial side. And so we said we did one full revolution, a little bit more, and just like a smidge past it. And so that's going to be my rotation 470. Now you're wondering, like, wait a minute, it looks like, do I have to draw like that squiggly line with like the rotation? And the answer is yeah, that's showing how much I've rotated that angle. And I have negative 640 degrees. Now this is going to be negative rotation, and so I'm going to be going in the opposite direction. And so for here, I know that if I rotate this way, okay, that's going to be 360 degrees. And so going 360 degrees, I'm going to be left with 280. And so that means I can go with another 180 And so that's going to give me 100 degrees left, which means I can go another 90, which means I'm going to have another 10. So if that's going to be 45, that's going to be 20, that's going to be 10. And so drawing my angle in standard position here, draws out that way. And so going in negative rotation, rotates, rotates, and then we have that little sliver there. And so that's going to be negative 640 degrees. Now I can also, I'm just going to skip just graphing alpha and beta. We just practiced graphing a few of those, so that's fine. But part B, it says find a supplementary angle for alpha. So for part B, what we can actually do here is finding that supplementary angle. I could say that alpha plus I don't know what angle I'm going to have to add is going to give me 180 degrees. Well, why did I say 180? Because it says supplementary. And so if I subtract alpha from both sides, that's going to give me what my x value is. And I can use that same concept for C. I can say, well, if I take beta and I add it to some complement y, that's going to give me 90 degrees. So if I subtract beta from both sides, y is going to equal 90 degrees minus beta. And that's going to give you what your supplement is and what your complement is. Now when we're talking about radians, the real number pi is defined to be the ratio of the circle's circumference to its diameter. That's what pi is. Now in symbols, given a circle of circumference c and diameter d, pi is going to be c over d. Now think about the equation circumference. 2 pi r. Believe it or not, what we've been doing is this idea of 2 pi, that actually is rotation. And it tells you how much you're going to rotate. So if I say 2 pi r, that means I have some sort of radius here. And if I'm rotating at 2 pi, I'm rotating the radius an entire 2 pi, which is why the red in this case would be my circumference. So that 2 pi is actually how much it's telling me to rotate. So that means 2 pi is the same as 360 degrees. Well, if I divide both sides by 2, pi is the same as 180 degrees, which means that pi is the same as half a circle. So let's kind of visualize this. If I said that pi is half a circle, so that means that half a rotation here is going to be pi, another half rotation here is going to be another pi. So that's where I get my 2 pi. Well, if I wanted to take this and I wanted to cut this in half, I'm now going to get pi halves. Right? If I take pi and cut that in half, I get half of it. So that's pi halves. So this is pi halves, this is pi halves, this is pi halves, and this is pi halves. So if I wanted to find what this rotation was in radians, pi half, pi half, pi half, well that's 3 pi halves. And so I could say that this rotation here is going to be 3 pi halves. For my next one here, I can now cut this into fourths. So if I take this pi half and cut that in half, that's going to give me a fourth, which is going to be along here. So here's 1/4, 2/4, and then if I wanted to keep going, okay, 1/4, 2/4, 3/4, 4/4, 5/4, 6/4, 7/4, 8/4. Well, 8 divided by 4 is the same as 2 pi, which is why that's a full rotation. And I can take this and I can cut it into 6. So I can take this and I can cut this into thirds. And so if I cut this into thirds, it's going to look like this. So 1/3, 2/3, and 3/3. And so 3/3 is the same as pi, which is why it's created it. And if I wanted to go all the way through the rest, right, 1/3, 2/3, 3/3, 4/3, 5/3, 6/3, 6/3 is the same as 2 pi, which is why I get that entire rotation there. And then the last thing is I can cut this into sixths. And so here's 1/6, 2/6, 3/6, 4/6, 5/6, 6/6, all the way through. And so this would be 12/6, and this is why this entire thing is going to be 2 pi. And then just as a visual, this entire thing here is going to be 2 pi. Now because of this, I can actually draw what my angles are going to be in terms of these radians. And so if I have this 4 pi thirds, Well, that's saying I need to cut my half of my graph into those thirds. And so cutting this into thirds, I'm going to get 1/3, 2/3, 3/3, 4/3, 5/3, and 6/3. So this right here is a third, this right here is a third, this right here is a third, and this right here is a third. So right here is going to be where that rotation is going to be. So drawing this out, this is going to be my rotation. From here, and that's going to be my rotation right there. Same thing with 4π6, but the difference here is I can say that this is the same thing as 2π3. And so once again, I can cut this into thirds. And so cutting this into thirds, I'm going to get 1/3 and 2/3. And so here's my 2/3 rotation, and so I can say that this is actually my angle here. So there's my 2/3. And rotating in the negative direction, so this would be a negative π-halves rotation. And so darken that in. Here's my initial side, here's my terminal side, and so there's my negative π-halves rotation. Now, coterminal angles are angles that have the same initial and terminal sides. So if you kind of notice, it seemed kind of pointless why we kept rotating in circles and over and over and over again, because it looks like that could just be simplified if I just rotated a little bit more. And so we can actually find coterminal angles by doing this. So for example, 30 degrees is the same as rotating negative 330 degrees. Now, how do I find that next angle? The hint is going to be you add or subtract 360 to find the next value. Or if it's in radians, you're going to add or subtract 2π. So if I have 30 degrees and I subtract 360 degrees from that, that's going to give me the negative 330 degrees, which happens to be my coterminal angle. And so you can keep finding coterminal angles by doing that. So if I wanted to find the coterminal angles for this, or two of them, just to save time, I'm just going to find one. If I add 360 degrees to this, this is going to give me 110 degrees, which is going to be a coterminal angle. For this one here, if I add 2π to this, well, finding a common denominator, that's going to give me 65π over 18 plus 36π over 18. Now adding those together, that's going to give me 101π over 18. This is going to be a coterminal angle. So just by adding or subtracting 360, you're going to be able to find coterminal angles.